right? So today I'll discuss in this class that a particular problem mentioned in HackerRank, and that was finding some of the series of sine series, right? So I'll start with a simple example, then we will go up to sine series. So finding some of the series will be topic, right? So now screen is visible to all of you. My voice is clear. Okay, let's start. So here our program topic today is programs on finding sum of the series, right? So series is also kind of a pattern, right? Like we have printed patterns. There was a shape, right angle triangle in different orientation, in different rotation based, and then diamond and all these things were used with for loops. Similarly, here also we will utilize for loop. Even series sometimes you can confuse with your algebra, like arithmetic progression was a series, right? And geometric progression, harmonic progression. So there were some fixed formula also for finding sum of the series. But in programming, we know utilization of loops very well. So here I'll try to connect mathematical concept with programming, and that will very much clear your all the doubts regarding such kind of problems, right? So what I have used here a simple mathematical Greek symbol sigma. Sigma is used for summation purpose, right? You know very well. So now I'll generate a sigma for a particular summation and then convert it into for loop, and then program will run. Okay. So anybody is not aware of sigma, please tell me first. So what is sigma is all about? So sigma is for summation purpose. Suppose you want to find this summation, that this is simply arithmetic progression. Even formula is also there, but I will not use formula. I will use for loop, right? So we have even done this thing, right? Summation of n natural numbers up to n. Suppose n is given 4, so I'll add here 1 plus 2 plus 3 plus 4. So sum is equal to sum plus I. We have already done, right? But can we represent this using sigma? Yes. Below sigma I have written starting limit, above sigma I have written end limit. So every time in all the type of series, this is a series, we have to find sum of this series, right? And to find this sum of the series, we have to define our sigma. So what is written inside this? Inside we will write only I, right? So this will be simply represented by a simple for loop, right? We can represent it by simple for loop. So what will be our for loop? If I'll write here for loop, suppose I is equal to 1 comma I less than or equal to n and I plus plus, then what will be within the body of for loop? Simply sum is equal to sum plus I, right? Anybody has any doubt regarding this sigma representation? Please tell me first if you have. If you have, I don't think there should be any doubt. You are all well versed in mathematics, and we are all engineers supposed to be well versed in mathematics. We cannot say no. If we are not aware of sigma, we are very well aware of sigma. Even in your mathematics or 11th standard or in 10th standard, you have done with sigma, right? So sigma is kind of summation represented. So whatever is written in bracket, right? On this bracket, values will run. So when I value is running from 1 to n, right? So sigma is working like this. Anybody has any doubt, anything that is not your awareness about, please tell me. If you are well versed, then I should move ahead. Can we convert this into this sigma representation? Is that okay? Then sigma can be converted to for loop. Anybody has any doubt, please ask. Then only I'll move ahead. If you are clear about this thing, okay, that summation will be converted using this sigma.
The value of sum will be 0.
Value of
Sum will be 0, I think.
Obviously, value of sum will be 0, initialized initially, obviously. Is that clear, that sigma representation? Because next time this summation will be a little bit difficult, then you should not be confused by this, right? So I think this is clear, because you are not telling anything, that means you are agreeing. Okay, suppose now next series is like this. What is this? 1 upon factorial 1 plus 2 upon factorial 2 plus 3 upon factorial 3. So what can be general term of this within sigma that I can write? I upon
I factorial.
right? Very nice. Factorial of I. Okay. So very efficiently we can manage this thing. I upon factorial I, factorial function we have to create earlier, and then within for loop I'll call that function. So again I can write this thing. Suppose I have written here itself. So how I can write this thing? So factorial function is written somewhere. So sum is equal to sum plus I divided by fact of I. Anybody has any doubt regarding this thing? Font size is visible. Anything is invisible, I'll increase font size immediately. This I is visible. I is equal to n. I is equal to 1. Okay, everything is okay. Right? So this sigma is clear. General term of this series. So obviously we have to write sum is equal to sum plus, and sum is initialized with 0 every time. This is not an exception.
So यहाँ पे float नहीं लगाना पड़ेगा?
Yes, we have to apply float. Obviously, wherever division is there, float will be applied. Obviously, those data type and those things are related to program and accuracy. You have to apply, and you can apply at your own. I am only connecting here what kind of representation will be done in sigma and how it can be represented in a loop, right? So I am only relating these mathematical and programming scenario. All the things are same that we have earlier done, right? Factorial function we have to create, then only we can call it over here in the denominator part. Sum will be obviously 0.0. It will be a float or double, obviously, because we are adding something that has a division operation. So division operation may get completely divided or not. So accuracy must be maintained. So obviously sum will be here 0.0, right? Correct. Anybody else who has any kind of doubt up to this point, please tell me, because I'll increase this complexity up to sine series, cos series, and all these things. Anybody is feeling awkward by using this sigma? This sigma is just a mathematical representation, and I'm representing that for loop with the sigma, right? Whatever you have written with sigma, I is equal to 1 is below, I is equal to n is above. That is for loop. And whatever you have passed here inside sigma bracket, that is done over here. Sum is equal to sum plus I. Similarly, here your series is like this: 1 upon factorial n plus 2 upon factorial 2. So generalize it is I upon factorial I. So I upon factorial I is passed inside sigma, and I is moving from 1 to n, and everything is added up, and that is the result. Okay. So now tell me sigma for this one when sum is 1, 3, 5, 7. So how I should maintain over here when I is from 1 to n, then what should I write over here?
So 2i minus 1.
Correct. This will be 2 into I minus 1. Okay. Anybody has any doubt regarding this? How this is 2 into I minus 1? Because I is moving from 1 to n. When I is 1, then 2 minus 1, first term, 1. When I is 2, 2 to the 4 minus 1, second term, 3. Right? So every time value of I will be kept here according to the for loop, and term will be generated, and due to our logic that will be added. So this thing can be written over here also, right? So here I'll write sum is equal to this thing I have to change here, and that will be 2 into I minus 1, right? Even bracket is not essential, but I have written. And one more thing we should write over here now. I should write plus equal to, remove this thing. Is this okay? This is also same thing, compound assignment operator. Sum is equal to sum plus 2 into I minus 1. Look, in first example, I was using 1 plus 2 plus 3 plus 4. So sigma was having only I. So sum is equal to sum plus I, right? Now I'm having alternate odd terms. So 1 3 5 7 if I have written. So sum is equal to sum plus I will not be there. It should be sum is equal to sum plus 2 into I minus 1, right?
हेलो।
हाँ बताओ।
बोलो बोलो।
सर का इंटरनेट लैग कर रहा है 96।
सर आ गए सर आ गए।
There was a disturbance. Okay. In network. So again, let's continue. Again, my voice is clear and screen is visible. We can continue with this. So here I have written sigma as 2 into I minus 1. Yes, Shashwat, anything you want to say? No, okay. So now you can see your sigma is 2 into I minus 1. So try to note it down. Everything, whatever I am showing here, you should note it down, right? Don't wait for final MS Word to be sent. You should note it down. Pen and paper, use it properly. The written things are quite less. I am explaining everything. So now this summation is clear. 1357. So 2I minus 1. Now we will. So earlier we are doing with all the terms. Now alternate terms are added up. So this is the logic. So in place of, suppose I write here 2468, then what should be written over here? If suppose my summation is like this, 2 plus 4 plus 6 plus 8, then what
2i.
will, right? Take
2i.
2i.
Yes sir.
Okay, everybody agreeing? Okay, 2 into I minus 1 will be removed because I is 1. So 2 into I will be 2, then 4, right? Like this. That one more thing I will introduce in the next series, and that is minus sign, alternate minus sign. So first
Yes.
value is plus, second is minus, then minus. So how can I represent my sigma now?
-1 की power I minus 1 into I.
Correct. Okay, Sailesh? Right. So here one thing, sum is equal to, actually I have to create my I. Okay, so I must be there. So 1 2 3 4 are there, so I will increase linearly. I will be 1, then I will be 2, I will be 3. That is okay. But here I can write this thing like this, 1 plus, that is minus 1, right, multiplied by 2, right, and that minus 1 is having power 1, right? That is minus 1 is having power 1 over here. So I can write this like this, minus 1 to the power 1. Okay. And this is actually written as 2, right? Then every time I'll utilize this power symbol. See, suppose I have written here again same thing, right? I have written here again same thing, and I have started also. If I have started, then I'll write, right? Otherwise I'll, right? So my series was earlier 1 minus 2. So 1 minus 2, so it should be actually either 0 or 2, either 0 or 2, right? Suppose I have written here 0, then it is okay. So now I have to see what my I is moving ahead. So accordingly I have to manage, right? So I'll see later on. So it is, first term is 0, minus 1 to the power 0, then it will be plus 1, minus 1 to the power 1, then it will be plus 2, minus 1 to the power 2, then it will be there is something wrong. Right. Okay. Minus 1 to the power 1, it will be minus 2, right? Minus 1 to the power minus 1 to the power 2, it will be plus 3, then again plus minus 1 to the power 3, so it will be minus 4, right? So earlier what was your summation? Now your summation has been modified. So what was my given question was that 1 minus 2 plus 3 minus 4 plus 5 minus 6. In this way it was actually written. So now I have modified this in this way. So minus 1 to the power 0 into 1 is plus 1, minus 1 to the power 1 into 2 is minus 2, plus minus 1 to the power 2 into 3 is plus 3, right? Whenever I will square this minus 1, even powers will make it positive, even powers will make it positive, odd powers will make it negative. In this way it is written, right? So can I generalize this thing, power representation? Yes, and that generalized thing will be used over here, right? That generalized thing will be used over here. So I can write here I into something I have to write in representation of minus 1. So I'll write here, suppose I have written this like this, minus 1, and to the power I'll raise over here, right? So how I can raise here minus 1? If I have started from 1 to n, then it should be started with like I minus 1. Is that okay? If I'll write here I minus 1, then first term will be, because I is starting from 1, right? So here I will be 1, okay. Then power will be what? Minus 1 to the power 0. So first term is 1. If I is equal to 2, what about second term? So I will be 2 here, okay. 2 is there, into minus 1, and I is 2 actually. So 2 minus 1, what will be? 1. So minus 1 to the power 1, that is minus 2, right? Second term. Then third term will be, I value will be 3. So 3 into minus 1 to the power 3 minus 1. So 3 minus 1 will be 2, that is plus 3. Then fourth term, I will be 4. So minus 1 to the power 4 minus 1, that is 3. So 4 will become minus. So everybody has got this point, how I have converted my series from 1 minus 2 plus 3 minus 4 to this multiplication with power of minus 1.
Yes, sir.
Okay, very good. If you have understood, then definitely it is very nice. And that is written in sigma. Now, what about for loop, right? So the same thing we have to represent in loop. So in loop, how I can represent this sigma? So in this loop, I will represent sigma in this way, because this is a programmatical thing. So you should represent it with, right? So here it will be I into power function will be there, right? And power function will have both the x to the power y. What is x here? Minus 1. What is y here? I minus 1. Are you getting this point? So here it will be minus 1 comma I minus 1, right? Even you can use brackets also, but it is still correct. Are you getting this point? How I have represented this thing into this thing, because power function generates power. So I can represent minus 1 to the power I minus 1 like this, x to the power y, right? This is x and this is y, x to the power y. So x comma y, two parameters are there in power function, and every time that will be multiplied by I, that was multiplied by I. Anybody has any doubt? Please ask. So first thing is you have to understand your series, identify it in some kind of pattern. Again, this is a pattern, so that it can be represented in a sigma mathematically, and that will be simply translated to the programmatical structure in for loop. Please tell me if there is any doubt. That means okay, very nice. So now please tell me sigma for this one if you have correct information. Pratyaksha Dwivedi, can you tell me? Pratyaksha Dwivedi, are you there?
Yes, sir.
Yes, sir. Yes, sir.
Okay, beta. Okay. So please tell me sigma for this problem. Currently, I am in.
Sir.
If there is no negative symbol, then it is very much straightforward. 1 upon factorial of I. I upon factorial I.
Yes, sir.
And when it is represented with minus also, then what will be there? Here it will be I divided by. Sorry, I should write like this. Okay, it is okay. I divided by factorial I. This
Yes,
is
sir.
one thing, and another thing is related to power,
Sine.
right? So related to power, now what will be written? Is this okay? Or I should go with a different thing?
Excuse me, sir.
Yes, Sameer.
सर पावर में I-1/2 होना चाहिए.
हाँ समीर बोले, कुछ और भी बोल रहे थे.
सर हम पूछ रहे थे अगर -1 से स्टार्ट होती सीरीज तो.
Yes, we can do. But see, you can generate it generally. This is, look, what I am talking about here is starting of the series and termination of the series is not fixed. You can do it accordingly. According to the asked series, you can change them. We can start from -1. We can start from 0 also. Accordingly, we have to manage with our term.
Okay, sir.
So, Shachi was saying something, right? If I'll write here I-1/2, why this is not correct? Because this is similar to the previous problem. 1
Yes,
minus
sir.
2
Yes, sir.
plus minus alternate terms were there. So here also alternate terms are there. So there is no change,
Yes, sir. Yes, sir.
right? So can you write this for loop for this one? How can I write for loop for this one? I will write here I divided by factorial of I, right? I divided by factorial of I must write in bracket so that it should be evaluated properly and rest of the things are okay. Is this clear? All of you?
Yes, sir.
Yes,
Based
sir.
on previous one, right? So this alternate plus minus we have done, and alternate terms also we have done. Now there is a combination in the next one. Please tell me sigma for this one.
-1 की power I-1 into 2I
But
-1.
first tell me about I, then power.
So 2I-1.
Okay, very nice, Rishabh. 2 into I minus 1, right? And I will write it in bracket also so that your power representation should not conflict. Now I'll write here that power representation, that thing I'll copy and paste over here. Is that okay, everybody?
Yes.
Anybody
Yes, sir.
else has any
Yes,
doubt?
sir.
Okay, so for loop now you can create for this one. What will be for statement for this one? You can write it, very nice. For statement for this one, we can write it, make it correctly written over here. So it will be again 2 into I minus 1, and rest of the things are like same, right? Factorial was there. Something is. Acha, okay. I have copied a wrong representation. This I will remove. Something. Acha, okay. Oh, cut copy paste. You can do it correctly, right? So I am removing this thing. So now you have understood things nicely. So now we will go for next question, and that is this. Now tell me sigma for this.
सर वहाँ 1 का फैक्टोरियल होना चाहिए था. x to the power 1 है.
X value will also be entered by user n value will also be entered by user.
नो सर, जो पहला टर्म है।
तो पहले टर्म में डिनोमिनेटर में सब 1 फैक्टोरियल होगा।
Yes, sir.
Yes. Exactly. It will be. So x 1 upon factorial 1, x cube upon factorial 3, x 5 upon factorial 5. Now tell me sigma.
x की पावर i अपॉन i का फैक्टोरियल,
X to the power
i प्लस 2 का।
सर 2n minus 1 का
2n minus 1.
2n minus 1 or 2i minus 1.
2i minus 1.
2i
2i
minus
minus 1।
2 into I minus 1 is in the power, and then okay, then it will be divided by fact of what?
2i minus 1.
2i minus 1.
2i minus 1.
Okay. Even I can write this as mathematical term. I can write this thing also over here. There is no need of asterisk, but in programming we will use asterisk. So everybody is clear about this series finding?
Yes.
Here
Yes,
actually value of n and value of x both will be entered by user. So this is not a difficult case. So for loop can be generated very easily. Right? आप लोग लिखते जाइएगा. For loop you can create it or I should create. For loop you can create it.
सर सर जैसे x की पावर i अपॉन फैक्टोरियल i कर दे और फॉर लूप में i इक्वल टू i प्लस 2 लगा दें अपडेशन के लिए।
Yes, we can do such kind of thing, but these are experiments. Try to make it correctly done, then only confirm, right?
समीर यू आर राइट सर, मैंने भी ऐसे किया था, सही आउटपुट आया।
Maybe it can
सर
be done.
तभी वो हमने बोला था
Yes,
x की
sir.
पावर i अपॉन फैक्ट i।
Maybe it can be done. Okay, sure. So one more thing that I was trying to tell, just forgotten. Not everything is okay over here. Remember this thing: if you are first time C programming, learning C programming, then mathematical terms will be converted to programming with proper operator symbol. Right? In mathematics it is okay, but in programming you have to write like this. One thing was that, and another thing is, another thing is, like suppose in this example I'll alternate plus minus, then minus 1 to the power will be done. Okay, now everybody knows about this thing, right? So that means now we should come with our sine series, right? So if you have done problems, understood problems up to this term, then sine series is no more difficult, right? Sine series and cos series are quite easy now. So now what will be sigma for this? We can definitely calculate. Obviously we should copy this one over here and add one more term, that is power representation of negative term, that is added, right? Or if you have done y as you were telling I plus 2 for loop, this is also okay. But after calculating these things, you should calculate by calculator also to justify whether your output is coming correctly or not. You are not getting any logical error, right? After any experiment you should cross verify it. Give n value small like 2 or 3 and try to calculate using calculator also mathematically on pen and paper. Then your program should give approximately similar kind of answer, then make it correct. So here x minus x cube divided by factorial 3 it is. So here alternate plus minus terms are also there, right? In previous one all the terms were positive, here alternate plus minus terms are also there. So only thing is that we have to apply that minus sign representation, nothing more than that. So this thing we have already done, make it in this way, and here we have to write that thing minus 1 to the power I minus 1. Within this. Is that okay? This is for sine series. This is for sine series. Now tell me for loop for this one. No difficulty. We have function POW function twice used over here, right? So can we write this thing over here? Anybody has any doubt regarding this, please ask. Here in this case, I have written this power function before and the rest of the things are later, otherwise it is similar. Anybody has any doubt regarding this sine series finding questions? In previous programs or in this one, or you can create this cos series. Tell me sigma for this one.
X की power 2i minus 2 divided by factorial.
Or can I do this using I is equal to 0?
Yes, sir.
Yes, sir.
Then it will be, I think, more easier.
Yes, sir. Yes, sir.
Representation. So what will be here now?
X to the power 2i.
X to the power 2i. Okay. Then
by
Divide by
factorial 2i.
factorial I.
divide by
2i.
factorial 2i, na?
2i.
2i, correct. Then
So power will multiply.
power will be multiplied.
Yes, sir.
Same thing that I have written above.
Yes, sir.
Look here, whether it is correct or not.
So minus 1 की power I.
Minus 1 to the power I. Is that okay now?
Yes, sir.
See second
sir.
term. Yes, now we have to cross verify.
Yes.
So first term I is equal to 0 is okay, I is equal to 1. So I is equal to 1 is x square, factorial of 2 is correct.
So minus 1 की power 2i.
Minus 1 की power 2i, then second term will not be negative.
Yes, sir. I
No, sir. No,
रहेगा,
sir.
2i नहीं,
सही
I
है,
रहेगा.
सही है, सर. सही है, सही.
Don't get confused, just see. Okay. So for loop can be represented simply like I have written over here also. So I'll show you in program, right? Or I should copy it and show you at the same place. So this is the statement written within for loop. Right? That for loop will run from, now I should mention for loop also. So now here for loop will run from I is equal to 0 and I less than n, okay, then I plus plus. Because you have to find series sum up to nth term, right? So value of x and value of n should be given, and then for loop will run if I have started from 0, so accordingly it should run. So this is all about regarding finding sum of the series. So any kind of difficult series can also be calculated like this. Like I want to ask you now this question. Suppose I want to find sum of this series. Sum we have to find for this series 1 plus, I have written 1 plus 2, then plus, I have written 1 plus 2 plus 3, sorry, plus I have written 1 plus 2 plus 3 plus 4, and then I have written like so how should I represent this?
So इसमें दो for loop use कर सकते हैं सर.
क्यों नहीं यूज कर सकते हैं, वो तो लॉजिकली आपको बताना पड़ेगा ना. Obviously we have to use. So can anybody tell me about sigma representation for this one?
सर
हाँ.
सर आई को 1 कर दीजिए, आई इक्वल टू 1 और सर सिग्मा के अंदर डबल सिग्मा चल रहा होगा.
I के अंदर I is equal to 1 कर दिया, suppose we have done. And sigma inside sigma, another sigma is there.
सर 1 से I तक चलेगा.
Very good. बाकी लोग भी समझे कि नहीं बताएं भाई, ये तो इन्होंने बोल दिया. Second sigma will run from I is equal to 1. Here, second sigma final limit I have to mention over here. I is equal to 1 to n, and second will be
I 1 to I.
Is this correct?
सर I लगा दीजिए आगे. I ऐड कर रहे हैं हम लोग. I तक चलेगा सर, और सिग्मा नीचे ब्रैकेट के पास I में I ऐड करना है.
Now within this I'll write I. Is this okay?
Yes sir.
Yes, sir.
Okay, so now complete it.
इसमें I plus 1 upon 2 फॉर्मूला यूज करके भी लगा सकते थे.
हाँ लगा सकते हैं obviously, but I'm trying to utilize loop only, whether it is nesting of loop or not. Only loop I want to use as much as
Yes.
possible. So
Yes,
now tell me a for loop representation for the same. For, outer for, or inner for, or nesting, whatever you want to say.
I is equal to 1.
I is equal to 1.
I less than equal to n.
Then equal to n, correct.
I plus plus.
I plus plus.
Okay, let me make it correctly then. I plus plus, then
Sir, इसका
Then
for
some-
I for j is equal to 1.
that you should also, J must be told over here also. Why you have told me like I both the I's.
Sir,
Now-
j is less than equal to
J
n.
less than equal to I.
I
Correct.
j plus plus.
J plus plus. Yes sir.
Correct. Sorry, sir. J plus plus. Now what will be written here?
Sum is equal to sum plus j.
Yes sir.
Sum plus J. So now I should correct this J.
Sir, j is equal to I. That's it.
Now it is correct, right?
Yes sir.
तो समेशन के अंदर भी J सर.
Yes. Good. This will be done. Okay.
Yes sir.
Any other student in class, if not understood, please tell me. These things are told by your colleagues, and they are not so difficult. You can understand them very well, and various kind of difficulties or complexity level can be created within this series, because we have already learned so many basic definitions of series, right? So I can introduce here any kind of difficulty, right? So this is again a combination of basic one. So anybody in class, if not understood, then I should convince you first, then move ahead.